everyone. We're going to tell whether the function is even, odd, or neither. This is an introductory video, and we're going to mainly we're just going to look at the graphs, basically. This part is how you do it algebraically, but I wanted to put that there. So basically, if a function is even, that means f of negative x equals f of x. That would be an even function, but that means the exponents are even. And remember, 0 is never even or odd. Remember, anything to the 0 power is 1. The graph is symmetric about the y-axis. Right? If the function is odd, then that means when you plug in negative x, you'll get a negative f of x. So that would be an odd function. The exponents are odd, and it's symmetric about the origin. Right? And if it's neither even or odd, then it's neither, when you plug in negative x, you'll neither get back to your original function or the negation of your original function. So that's, the exponents can be a mix, or it could be even with a constant. It could be a lot of things. So we'll look at that. And the graph is symmetric, and you'll just say not the y-axis or origin. Not y-axis, not origin. Sometimes they give us these little tables, and it can't fill everything in. Okay, so let's look at some graphs. So I'm just going to draw some graphs. I'm going to draw an even function. So this is a quadratic function. 1 goes to 1, symmetric. 2 goes to 4. 1, 2, 3, 4. 4. So, whoops. So basically, something like that. Now, this is called even because it's symmetric about the y-axis. Okay, so this would be y equals, well, let's make it f of x. F of x equals x squared. So now if I plug in negative x, everywhere there's an x, I plug in negative x. I'm going to get two negatives make a positive, so I get x squared again. So that means I'm back to my original function. That's what makes it even. Now, if I shift this up 2, so I'll do this. I'm going to shift it up by 2 units. All right. Is that even? Yes, that's even because it's still symmetric about the y-axis, meaning if you fold it up, it should match up. It's symmetric. So this equation, as I shift it up by 2, f of x equals x squared plus 2. With vertical shift up. So plug in the negative x, get negative x squared plus 2, which equals x squared plus 2, which gives you back to the original. If I shift it to the left by, let me do it by 5. 1, 2, 3, 4, 5. And I'll use blue. If I shift it up this way, this is going to be odd. So basically, this is f of x equals x plus 3 squared. You put in a negative, and you won't get the same thing. So it's not, you can just tell by the graph it's not symmetric. All right. Now, let's look at odd. Odd functions are like your cubic function. Now, this is what it means to be symmetric about the origin. It means that you can reflect it over the axis twice. So I can reflect this piece over the axis. I'm talking about this one. Reflect it over, and just take my word for it, that's a reflection. Then you reflect it over the y. So you're reflecting it over twice, and you get to the same place. You could reflect it over the y first. So I'm taking this piece, reflecting it over the y, and then second, then reflect it over the x. So that's what would give you the even. It's reflected over the origin. So we have y equals x cubed. Or f of x equals x cubed. So if I plug in negative x cubed is negative x cubed. So this does equal, if I want this to be negative, if I want this to look like this, I'd have to put a negative in front of each one. So that's what makes it odd. Now, if I shift this, so let me get rid of this a little bit. If I shift the odd up by 3, this is not odd because it's not even reflective over the origin. It's reflected over this 2 point here. So it's not reflected over the origin. If I shift it to the left here, or to the left, this is not reflective over the origin. Let me clear this. If you know your sine function, I'm just going to estimate this. The sine function looks something like this. This is an odd function because you can reflect it over twice. If I reflect this piece over twice, over the y and then over the x, I'll get this piece here. This should go in the origin. I will get this piece here. So the cosine function is even. So let's look at some of these graphs and just state if it's even or odd. So is this reflective over the y-axis? If you fold it up, this is even. This one's not reflected over the y. Is it reflected over the odd? Yes, because if you flip this piece over twice, over the x and then the y, you'll get this same piece. Or you could reflect it over the y first and then the x. You'll get the same thing. So this one is odd. Now this one's just a translation down, and it's still reflected over the y, so it's even. This one's not about the origin nor the y-axis, so this one is neither. This one looks a little odd because it's got the origin thing going on, but notice these two aren't the same. So if you reflect it, you won't get the same thing. So this one is also neither. All right. And I put this at the end here in case you want to screenshot it, because this will be a handy thing to have when you're doing your even and odd functions. Let me get rid of that. That's it. Thank you. Have a nice day. Bye-bye.